Hello, welcome to today's class, which will be on the final unit of personal finance, which is called annuities. So we left off in the last video or the last class on compound interest. So we've covered simple interest, compound interest, and now we're going to get into annuities. So for annuities, just a couple quick definitions here. The definitions I will explain, sort of in layman's terms, so to speak. But the definition of an annuity is a series of equal dollar payments. So you have these payments that are made at the end of equidistant, which means equal points in time. So the payments are made monthly, quarterly, annually, or weekly, depending on, what the payment schedule is over a finite period of time. So finite period of time maybe meaning 5 years, 10 years, 15 years, and so on. The payments go in or come out of an interest-bearing account or investment, and the constant interest rate is compounded at the same time payments are made. So we still have our interest being compounded. So you'll see the word compounded in these questions, but unlike compound interest, we're making payments. So I mentioned this a little bit in the previous video about, I kind of wanted to introduce annuities a little bit before we got into it. So with compound interest, we're making one lump sum payment. So let's say maybe I wanted to open up an investing account that was going to collect compound interest of 5%, compounded monthly over 10 years, but I was giving this one lump sum payment of $10,000. So I only put that money in once into that account. With annuities, we're doing equal payments at certain points in a year. So maybe I talked about the fact that like a lot of times when we're investing and we're trying to invest for our future or retirement, we'll maybe take money off of every paycheck. So if your pay periods are biweekly, I would tell my bank or whoever I'm investing with that every 2 weeks, I want $500 taken out of my account. So biweekly, so that would mean 26 times a year, I'm investing $500 or however much. So that's basically what annuities, the difference. So I just said this, but the difference between compounded annuities, like I just mentioned, is that an annuity is a regular, it still has a compound interest investment, but it's not just a lump sum. It's regular payments that are made in, or sorry, you're putting into or taking out of an account during a time. And the amount of principal being compounded with interest changes every compounding period because unlike with compound interest, we just have $10,000 and sure, we're gaining interest on interest, but our principal stays the same. With compound interest, my principal is going to change, right? So maybe at the beginning of the year, I have 10,000, but a month in, I have an 11,000, right? So my principal value changes. So that's why we talk about payments in this formula. So this is the formula for future value. So this is the formula we use. So FV is the future value of annuity at the end of the end period. So this future value just means how much am I going to have in the future? So in however many years I'm investing this for N years. PMT is our payment, our annuity payment deposited or received. So the amount of money, the payment. I is the interest rate period, just the same as compound. We still have an interest rate per period. And then N is the number of periods in which the annuity will last. So we'll talk about how to calculate I and N. PMT, payment is usually given, right? So I'd say I'm making a payment of $500 every 2 weeks or whatever the question says. I and N do need to be calculated, just like in compound interest. So how to calculate N? N is the number of regular payments of or compounding periods. So just like compound interest, we're going to take the number of years times the number of compounding periods. So just like compound interest, so for example, a weekly payment is compounded weekly over 4 years. So we take 4 years, there's 52 weeks in a year, so it's 4 times 52. So that would be my N. For I is the interest rate per compounding period. So we take our yearly interest rate and we divide it by the number of compounding periods. So for example, what is I if the interest rate is 3%? The investment is compounded monthly. So I have an interest rate of 0.03. It's compounded monthly. So just like compound interest, I'm still going to divide my 0.03 by 12 because I've been told it's monthly payments. And I get an answer of 0.0025 as my I. So let's look at our first example. And we'll go through some more examples of the difference between compounding and annuities at the end as well, just because that's the biggest thing I find for students on the assignments or the unit tests, is to determine which one's asking for compound and which one's asking for future value, because you will get very, very different answers depending on the question. So let's use white today. Okay, so at the end of each month for the next 5 years, Rob will deposit $200 into an account for a down payment on a house. So his hope is that he will eventually save up enough money to put a down payment on a house. He found a bank with an interest rate of 6% and it's compounded monthly. So for part A, it's asking how much money will he have for his down payment. So let's figure out some values here. So my formula is FV is equal to PMT bracket 1 plus I to the power of n minus 1 all over I. So this is the formula I'm working with. So what I'm going to need to do is figure out all of these things. So let's figure out what my payment amount is. Well, it says that Rob deposits $200. So that's his payment amount that he's depositing. And for n, we know it's the number of years. So it's saying Rob deposits into an account 5 years. So at the end of each month for the next 5 years. So we have 5 years, and then we're going to figure out the compounding period. So it says for down payment, each month. So each month, the end of each month for 5 years. So that means we're making 5 times 12, so that's 60 periods. And the interest is also compounded monthly. So my I is going to be 6 divided by 12, which is going to be 0.005. So now I'm just going to plug it into this formula. So I have 200, 1 plus I, which is going to be 1.005 to the power of oops, sorry, let's not use n, let's use 60, power of 60, take away 1, all over the power of I, which is 0.005. So to plug this into your calculator, you can either do it all at once, you're just going to use double brackets here, or you can do it in parts. So you can do 1.005 to the power of 60, press equals, subtract 1, press equals, times by 200, press equals, then divide by 0.05 or 0.005. So you're going to get an answer of $13,954, 1 cent. This is how much he will have for a down payment. So after 5 years of investing $200 every month for 5 years with a 6% interest rate in that account, he will have $13,954. So part B says, how much interest did he make? So a lot of this was his money that he put in. He put $200 every month at the end of every month for 5 years. But the question is, how much interest did he make? So let's figure that out. I'm going to have to clear this all. But let's figure out part B. How much interest did he make? Well, we found in part A that the future value was 13,954. We just calculated this one. That's where that number is coming from. And let's figure out, though, how much money did he put into that account? So how much was his money? Well, we know that he deposited $200, right? And he did that every 12 months for 5 years, which we ended up calculating to be 60, right? That's just our N. So if we take 200 times 60, we end up with $12,000 is how much he put in. So it's kind of like his principal value, right? If you think about it, but we don't usually use that term when we talk about annuities, but the total amount of payments, the total money he put in was $12,000, and this is the amount that was gained with interest. So to calculate my interest, I'm going to take that $13,954 and 1 cent, and I'm going to subtract the $12,000 that was straight out of his pocket, which means that in 5 years, he earned $1,954 in interest. So that's how much money he earned in interest for to put this down payment. So had he not invested this in a compound interest account, he would not have made that money, right? He would have just, if he just kind of took it in, put it into savings without investing it, it would have just sat there as $12,000. So when he invested it at this compound interest rate, that's how much money he gained, which is pretty cool. That's the thing about interest, is time is our best friend. So the longer it sits in there without, well, especially since you're not spending the money, so that's the biggest thing. But the other thing is that it's collecting interest over time. And we talked about this with compound interest. It's an exponential function. So there comes a point where this will grow exponentially if it sits in there long enough. Most of these types of accounts, though, if you talk to banks, typically they only allow like a 4 or 5 year term. To do long-term investing, you usually have to do mutual funds through your TFSA and stuff like that. But that's a totally different type of course. It's just the biggest thing to keep in mind with this, because it wasn't really talked about a lot when I was in high school. I don't think we talked about this ever, to be completely honest, is the importance of time with investing and compound interest being your best friend. So rather than having all this money sitting in your savings account and making no money, if you don't plan on spending it anytime soon and you plan on letting it sit there, there's lots of options for investing. There's low risk, high risk, medium risk. There's accounts that actually just having the money sit there gains interest. So there's lots of versions of that. And I'm really not an expert in that area. I'm really just learning about it a lot now. When I got into my 30s, I decided it's time to start thinking smart with my money. And I have learned a lot. I've made some money along the way too. So that's an added bonus. Okay, so here's another example. We want to compare two options. And this is cool. Maybe you'll be able to do this if you ever do an investing and they talk to you about different accounts, or maybe different banks have different rates. A person has an extra $100 a month. So they look at their budget and they say, okay, I have $100 a month and I'm going to place it into a GIC account, which is a common account that people use for investing. Which of the following would be a better option for a 5-year period? So both will sit there for 5 years. The first version is $1,200 invested once a year at 6% compounded annually. Okay, and part B, we have $100 at once a month and it's compounded monthly. So for A, let's calculate the two versions and then we'll take the difference. So for part A, let's figure out our payment. So we have a payment of just $1,200, right? And it's going to be 5 years, but it's happening annually. Annually means once a year, so it's just times 1. So our N is 5. And we have an interest rate of 0.06, and it's also compounded monthly, so we just divide by 1. So we stay at 0.06. So my future value then is going to be 1,200, and then we have 1 plus our I, which is 1.06 to the power of n, which we calculated to be 5, subtract 1, all over 0.06. So I'm going to plug this into my calculator and I get $6,764.51. If you're at $6,764.51. If you're having problems calculating this, like you can always talk to your teacher. We can show you how to plug this into your calculator all at once. But at this level, you should be able to do this in your calculator. So with option A, this is the amount of money that a person would make if they invested $1,200 once a year annually. So let's erase this and look at option B because I don't have room. If I would have done it the other way, my hope was to have room to do both side by side, but it's okay. For B, I have a payment amount of $100 because we're doing that, $100 invested once a month. My N, it's 5 years, but it's monthly, right? So we have 5 times 12. So I have 60 payments. So my N is 60. And my I is going to be 0.06 divided by 12 because it's compounded monthly. So I get 0.005 as my interest rate. So let's figure out my future value. My payment's 100, 1.005 because 1 plus my I. My N is 60, take away 1 over 0.005. You're going to plug this all into your calculator and you should get $6,977. So the question is, which one's better, option A or B? Well, option A, so for option A, we had, just a reminder, $6,764.51. That was option A. This is option B. So it looks like option B is better. And it's better, let's figure out, does it ask by how much? It says, no, it just asks which is better, but let's calculate how much. So I'm going to take option B minus option A. So 6977 minus 6764. So I'll punch that into my calculator and I get $212.49. So option B is better by just over $200. Now the reason for this is it's compounded monthly. So that means we're earning more interest on our interest because there's more compounding periods. And we're investing. So the question is, are we investing any more? I guess we didn't really talk about that. So we were either going to invest $1,200 at the very end of the year or $100 a month. And since there's 12 months in a year, in both situations, we're investing $1,200, right? So either way, over 5 years. So each year we're investing the same amount of money, but they have different compounded periods. So it looks like if I have more compounding periods in this scenario, it means more money. And that makes sense because the interest will be compounded over and over again, gaining money on the interest. I hope that kind of makes sense. So I like to do this one just because the biggest thing we have is the question that I get asked the most often, I should say, is how do I know if it's asking me to just do compound or annuities? Well, we talked about this a bit in the beginning. We're going to look to see if we're giving payments. If we're doing payments, right, if we're not just doing one lump sum, then that's an annuity. Otherwise, it's compound. Simple interest doesn't have any compound periods, right? So that one's pretty straightforward. But the problem with all of these, they always say compounded semi-annually because it is compounded. We do have compound interest in both, but we don't have payments in compound, but we do in annuities. So option A, $3,000 invested for 5 years at 5.5% per annum compounded semi-annually. So it's still kind of tricky in the wording of some of these questions, but sorry, I'm trying to change the color of my pen here to red. But we have $3,000 and it's invested for 5 years. So we're not saying $3,000 per year or at the end of the year or anything like that. It's just $3,000 flat and it's invested for 5 years. So that means that this is a compound interest question. This one's compound. Now it says at the end of the month, Doug deposits $25 into an account. So he does this at the end of each month. It pays 3.45% compounded monthly. What is the value of his account after 2 years? So because he's depositing at the end of the month, that means he's depositing it a payment, right? He's doing it more than once. He's not just depositing $25 for 2 years. It's at the end of each month. So this is an annuity question. I'm just going to say A. Now C, what will $6,000 accumulate in 5 years and 4 months if the interest is compounded at 8% monthly? Well, we're just investing $6,000. That's a flat amount. That's our principal amount. So this is compound interest. C, a deposit of $1,000 at the end of each year. So every year we put $1,000 into this account. This account sits for 6 years, compounded annually, but we're not just giving one payment of $1,000, it's each year. So we're actually putting $6,000 in total, right? So that means we're doing a payment every year. So that would be an annuity question. So that's the biggest thing you're looking for in these, the difference between compound and annuity. Simple interest will usually say an interest. It might even say calculate the simple interest. Those ones are usually the easiest to point out. These ones seem to trick students. So hopefully that clarifies things. If you have any questions, as usual, ask me or one of your teachers, and you can always turn to that personal finance booklet, which has more examples. and some practice exercises, as well as a practice sort of test at the end with answer keys at the back, so you're able to check your answers. Okay, great. Thanks for listening.